So it's nice to see a lot of you made it to the talk and in general to the conference. So in revenue management, we call such a gathering an event. And this is actually the topic of this talk today. The purpose is I want to explain to you a novel approach when dealing with events in Lufthansa Group's revenue management. So first of all, to understand it a bit better, I want to explain to you how revenue management works in general. I mean, we already had a deep dive by Robbie, so you know exactly what dynamic pricing is by now. But in general, just look at this exemplary graph. So imagine this is a booking curve for a flight from, let's say, Vienna to Frankfurt. So it's business dominated, and you can see a regular pattern, for example, Mondays and Thursdays throughout the year. On the opposite, if it was a booking behavior from, let's say, Zurich to Palma de Mallorca, a lot of people would travel rather on the weekends or in the holiday season. But what comes on top of this is now this event feature. So what is happening when such an event happens? We have a so-called anomaly in a booking behavior, a peak. What happens in the background is actually a very manual process. So the human expert checks his bookings. He knows the regular process, and he also has some insights such as the global events list, which he manually fills himself. So you can imagine all the errors he also makes when putting in the date or the frequency or whatever it is associated with. On top of that, what he does, he infers from his expert knowledge, and he mainly relies on past year's data. And this is a pity because then we mainly look kind of to the past and lag behind rather than knowing in advance. And this is where our idea comes in, which is pretty intuitive. All of this data would be publicly available. So the AMLD has been announced over a year ago. They have their own website. You can take from there the date and all additional information that you'd need. And on top of that, the people even tell us their intent to go there, and we can measure from the behavior on social media or other meta searchers whether people would want to go there or not. So another simple example which we missed in our airline data was a marathon in Barcelona, because it happened the first time in Barcelona. So how could the business analyst know that this will happen on his route? There's no way to know, even though it would be publicly available. In a more visionary view, this is actually an example that Migacore gave to us. They figured out that Netflix, so the streaming provider, he announced that they will host a show in Florence. So it's called the Medici, a kingdom. And the year after that, actually flight demand increased significantly to Florence. And this is something that we would have never attributed to flight demand before. Our approach is now not to take this information and give it to the user, but rather incorporate it directly into the model, that our forecasts become more accurate. In more detail, but still a high-level view, George will go into that in more detail in a minute, is 3 steps we do. First of all, we create the signals. So we take it from search engines, from news, from social media, and everything we collected, and then bring it consolidatedly into a format that our model can read. So what we do in the second step is actually the guys from Migacore come to our offices, and then we model intensely, incorporating our airline data to train the signal in a way that it actually depicts the behavior of our customers. So here is an example of one of our models. So at Lufthansa Group's revenue management, we have different models, but mainly 2. So one of them is the demand volume forecast, estimating how many people will want to go to a certain flight, and then the price elasticity estimation on the other hand, which estimates how much these people are willing to pay for the flight. I don't want to go into full detail here, but all of these models are regression models. So one is a GLM, the other a GAM, and what we give them as an input is booking data, so-called count data. And here, what the crucial part is, you see that it has different variables impacting the dependent variables. So for example, D time is the time of the day when the flight departs, or year day is the day of the year, so seasonality that we want to give our model, and everything of this works well, except for when we have such a so-called event. So what we do is here, we include these terms, so either an index or a so-called data signal, directly into our model. And how we come up with these models and how they are trained is now George's task to explain to you.
Cool, thanks, Tabea. So I guess sorry, I want the timer so I don't go over. What I'm going to talk about is basically the first 2 boxes here. So to very quickly summarize, what do we have? We have access to the entire web, and we also have bookings information. And we want to take these and produce some kind of quite generic signal that we can feed into Lufthansa Group's one of many different models. Okay, so by the way, web data can mean a lot of different things. For this talk, I'm going to focus specifically on events. I'm going to talk very briefly about sort of the general pipeline that helps us train a model that eventually outputs a signal. And then I'm going to deep dive into one specific sort of issue. So first of all, how do we even know what kind of events are going on in the world? The way we tackle this at Migacore is we just crawl a bunch. So we ingest currently about 10 million news pages, blog articles, and other just plain text. We use standard off-the-shelf natural language processing to extract named entities. Of course, almost none of, very few of these named entities are actually events, right? So for everything like a conference, you will have strings like Lausanne. So how do you filter those? Actually, what we do is, excuse me, the way we filter this is, imagine doing a Google search on AMLD, and the hits that you get might look like a conference, or it might look like something totally different. So we actually built a classifier that just looks at a bag of words for a web page and figures out whether this looks like an event or not. An even simpler trick you can use is look at structured sources. So for example, do a query on Wikipedia or some other structured information source and figure out whether this thing looks like an event or not. So once we've done this, we can take different claims from either the events website or structured information sources. So some claims we look at are events start and end dates, who organized it, where is it, city or venue, has this event happened before, things like that. And by the way, different sources can make conflicting claims. So for example, you might have two different start dates. And the way people typically get around this is by saying a source is more trustworthy if it agrees more often with other sources about related claims. So we use that intuition, and additionally we encode things like, we overweight, the event organizer's own website, and also we overweight sources that are more recent. And this is because some facts can change over time. And we also take trends information and social media interactions. And we take all of this, and this is what we use to essentially represent an event. Cool. Moving very quickly on to bookings. Booking data, as we've just seen, is very complex. We can look at bookings as well as observed prices. We know different lengths of stay, bookings at different times of day, and so on. I don't come from an airline background, so this was super confusing to me. But the main idea is that there is typically a sort of periodic component. So think of this as people want to travel on weekends or at certain times of day. Which existing models can take into account, and there is a sort of anomalous element. And this is the thing that might be caused by an event, and this is the part that we care about. So we actually use a off-the-shelf package, open source by Facebook, called Prophet, which is very nice because it does this periodicity decomposition, and it also helps you account for slight anomalies like, say, holidays. So using that, we have basically anomalies which we assign to days and cities. So for every destination city on a specific day, we say that we either observed or didn't observe a high impact. Cool, so we almost have ourselves the label. One more thing I want to quickly mention is we're interested in learning a magnitude as well as a shape, so sort of how this impact is distributed. So we actually trained two models, one something like XGBoost, and then we use a nearest neighbor approach to figure out what the shape of this might look like based on similar events, essentially. Cool, so now I want to talk about, very quickly, about a specific problem you might run into, which is what happens if you have two different events on the same day. So, for example, today there's a big, fancy, interesting conference like AMLD, and there might also be some less popular local meetups. And we observed that there was a lot of travel interest today, but we don't actually know which of these two events to attribute that interest to. So one thing we can do is just, just copy that label. So have both AMLD and the local meetup assign it high impact. And then you would hope that on a different day you see a similar meetup with low impact and learn something from that. But this fundamentally is broken because one of these labels is actually wrong. And if you have wrong data, you end up with stupid models. So what we actually do is we tell a different story where every event has one chance to trigger high impact on its corresponding day. And of course, the likelihood it succeeds is specific to that event, and we can think of these as probabilities that we want to learn. So by the way, we can write the probability of observing the high impact and low impact days as a function of these probabilities I just described. And we have one more trick up our sleeves, which is that if two events are similar, their probabilities of impacting travel should also be similar. So we can take these two ideas, write a maximum likelihood that we optimize over, and we learn some probabilities, essentially. So then into our training, instead of saying AMLD was on a high impact day and this meetup was on a high impact day, we use those estimated probabilities. So now we use this to train an event model, and that tends to work better. Right, so hopefully we would have learned that the probability corresponding to MLD is high and to the local meetup is lower. So this is very briefly how our pipeline works. As you can see, it's very segmented, and probably for each step you can think of many fancier ways to do this. And I'm happy to talk about that afterwards. In practice, though, this seems to already work quite well, and I'll let Tabea talk about specific outcomes.
Thank you. So we now know the theory behind what is happening when creating and training a data signal. So what happens when you actually test it? So what we did last year, we did a proof of concept together for 3 months. We had 1.5 years of booking data, and we specifically looked at the demand volume forecast. So what we did is, I want to show you one example. On the x-axis, you see the time, and then this is one route. So Frankfurt to Stuttgart, these are the outbound flights, so people flying from Frankfurt to Stuttgart, and then people coming back from Stuttgart to Frankfurt. So these are the bookings that come in. And just before the shaded area, you see that the orange line depicts the actual bookings that we observed, and the blue line is the forecast. So it's, in general, it's kind of accurate, but here it is very inaccurate just before the shaded line, and then just after, we also see a peak in the actual observed bookings rather than what we predicted. So, as the topic of the talk is pretty clear, what we observe here is a demand, and thanks to the data signal provided by Migacore, we have all this contextual data describing it. So this is an example-theory magnitude of the event, and we see that the continuous signal now contains all the data about the event. So where is it? When will the impact happen? Apparently it's some kind of expo, so we can categorize it, and we can add whatever information we need around it. So what happens is the green line appears, the new one, and we see that when we would simulate to include these data signals into the forecast, we are actually way more accurate in describing demand behavior. So we measured it with the RMSE, so a significant increase of 4.3% in the case of event happen. And what's also interesting to mention is we looked at, I think, 14 routes, And throughout these 1.5 years, we saw that we detected more than 800 events, and somewhat 18 of them were already contained in the manual list. I mean, we are aware that we will not detect big events that we already know about, the Geneva model or things like that. But first of all, we detect way more small events, and second of all, we are able to model the big events in a more accurate way. So just briefly talking about what we did, the current state, this demand model, just as I told you, we proved that there is a huge potential for including contextual data signals into our demand model. But before incorporating this or kind of building an implementation solution, we want to also check the other big model in revenue management, the price elasticity estimation. So what we are doing, another proof of concept, and here are actually the details. So we'll look at, first of all, 6 so-called origin destination markets and do live tests, because there is one big difference between demand and price elasticity. In the demand case, you're lucky, you can actually hold your forecast against the observations that came in. But what do you do for price elasticity? You don't observe a margin. A person doesn't tell you their willingness to pay. So what we do is actually, as of today, we went live with these 6 routes, and we'll do iterative testing in live tests. So this is actually a novel approach from what I know from the revenue management in airline business. And we will then accumulate the revenue during these test routes for when we turned on our solution and compare it with the regular model. So what is also happening in a more visionary context? My vision would be to include these data signals in all revenue management models and then also go further. I was also approached by, for example, corporate sales, because they have a lot of events determining their behavior, or marketing, or going even further to different departments. So thank you.